Hello, everyone. This is Kyle Shoemaker. I will be giving the webinar today. I want to start by thanking everyone for attending. A couple of housekeeping issues here. Everyone's microphone is set to mute, but there is a text-based question and answer pod to the right of your screen. So anytime during the presentation, if you have questions, feel free to submit them. We'll answer some of those excuse me, via text back. Some of them, Susan Cook is online here with us, and she'll be answering some of them, or asking some of them out loud for me to answer at the time that kind of is appropriate throughout the presentation. So we'll also have a full question and answer at the end, so you can ask now or leave your questions till then. Also, this webinar is being recorded, so you'll be able to watch this later or send a link on to anyone else. And that email will go out shortly after the webinar is over with information on how to view the recording in case you miss something. So let's go ahead and get right into it. Let me switch to our presentation here. So, again, basically same information as I just mentioned. It shows a picture of the chat pod here. But the agenda will have a small set of slides followed by a live demonstration and the question and answer. Okay, so who is advanced clustering? For those that have joined that are not that familiar with us, we're a turnkey high-performance computing solution provider. We've been in business since 2001, focused exclusively on HPC systems. Solutions include compute nodes, network, storage, infrastructure, software, support, everything that you need to build a turnkey high-performance computer system. So why did we develop eQUEUE? So this is a common set of questions we got from our customers and feedback, that for inexperienced users, clusters are hard, that they don't have a lot of familiar with Linux sometimes, that learning how to use a cluster in the command line is difficult, and that there has to be an easier, better way to submit jobs. So that's what eQUEUE is designed around. So there's three major features. One is the web-based job submission and management tool. The second is an easy way to do remote visualization and run GUI applications on your cluster. And the third is log analysis and cluster utilization. And we'll go into each one of these in more depth. So our web-based job portal. The idea behind this is that administrators will build a user interface for particular applications. So it's broken into two separate pieces. There's a form that is the layout of the user interface. You ask questions that are pertinent to the type of application that you're running. And then there's a submit part, which is basically a job submission script that uses the data collected from the form. When building your forms, you have full control over the UI, including text boxes, check boxes, file picker, file uploads. You can pick files from the cluster. You can upload them from their desktop. It's very configurable, and we'll actually create a sample job form later on in the presentation. They're created via very simple INI style format. So the idea here is for the administrators and the users that are creating these forms, let's not make it difficult, let's make it easy for them to be able to do this. You have full access permission controls, so you can limit certain users or groups to certain forms. So if you had a certain set of applications for example, a chemistry department, you could limit those users to only see those forms. And from the user perspective, it makes using the cluster a lot easier. They click on the form of the application, they answer the few questions, submit a job, and they're done. No learning to write a job submission script, no SSHing into the cluster. All of that's handled auto for them. So the remote visualization and GUI app piece allows you to use your compute nodes of your cluster to run GUI applications just like any other job. You can offer full desktop environments like GNOME or KDE. You can do specific applications. If those compute nodes have hardware-capable OpenGL cards, like an NVIDIA GPU, 3D applications can be supported. The end user's computers don't need those GPUs because all of the OpenGL calls and processing is done on the compute nodes. Any of these applications submitted are still run through your queue, so works with your scheduler, any rules you have in place. The client doesn't need to install anything on their computer either. It's all done through a Java Web Start component, so we support Mac, Windows, and Linux clients. So very easy for the end user to be able to point, click, and start an interactive or GUI application. And we'll also give a demonstration of that. And the final piece is the accounting log analysis. We found that a lot of our users don't really look at the accounting log much and make any insights or further understanding of how their cluster is utilized through this data that's being collected. So we have a fairly detailed set of reports that you can use from your accounting logs. You can look at memory utilization across jobs, across users, across groups, time of day, day of week, month of year. So you can get a real good insight to how your cluster is being used, who's your heavy users, who are users that tried to submit things and never got anything to run. So you can have a lot of insight here that is not necessarily easy to pull out otherwise unless you have a custom solution in place to look at your accounting logs. So, like I said earlier, we wanted to make this easy to use and broken this up into two separate groups here. Make it easy to use for administrators. So installation is an RPM. So if you're running a Red Hat CentOS Scientific Linux 6 type system, you put our yum repository on, type 1 command, and it's up and running. We didn't want to reinvent the wheel, so we integrate in with existing schedulers. Currently that's Torque or Grid Engine / Open Grid Scheduler. This includes Torque with Maui or Moab. Other schedulers are possible if there's enough demand. So we use all of your existing access control mechanisms. That means if you're authenticating users to LDAP, Active Directory, we use all of that existing setup, so there's no separate usernames, passwords for this web interface. And then all activity is run as the user, not as root, so there's no elevated privileges. And that everything is run in Apache over SSL, so really we only need port 80 and port 443 open on the node or the system that's going to run eQUEUE. For the users, we make it easy by working in all your popular web browsers, Chrome, Firefox, Safari, Internet Explorer. No plugins to install on client computers. They don't need to use the command line or file transfer applications like SFTP. They don't need to understand how job scheduler to write a job submission script. And there's built-in help within the web interface as well. So it's a pretty painless process for a new user. So enough talking in slides. Let's get into the demo of the live system. So, I'm going to click over and start sharing my screen. So you should now be able to see a Firefox web browser here on my machine. So what I'm going to do is pull up eQUEUE. And the first thing it does is ask for my username and password. And again, we're using PAM, Linux PAM stack here. So it's the same username and password that's already on the system. So I'm going to go ahead and log in as a username ACT. And you'll see the main eQUEUE web interface. At the top of the screen, we have some status bars here that gives you CPU memory and queued percentage. So this is the total load of your cluster at this point in time. So you can see right now we have very little CPU, very little memory usage, and no jobs queued. But this will change dynamically. Every 30 seconds the client reloads this. So these bars move forward and up and down as activity changes on the system. So we start on the home page here. And this is a custom page that you have access to completely define whatever you want here. This was a request from one of our beta testers so that they could put contact information, outage information, other useful stuff like that. So when their users logged in, they could easily get a status of what's going on, who to contact if they have problems, scheduled downtimes, that kind of a thing. So across the top here, we have all of our other sections of eQUEUE. So we'll kind of first move over to the queue node status section. So this pulls up information about the queues and the hosts on the system. So the system we're using right now is running Grid Engine. It's actually Open Grid Scheduler, the open source version of Grid Engine. So at the top here, you'll see the different queues that have been configured on the system and how many jobs are queued, running, or in the error state. You'll see some CPU memory and swap usage over the last hour. And then we also see some information about the individual nodes inside of our queue. This is a 3-node cluster. Actually, node 4 is down at the moment, so you can see that. But we also have a node called GPU 101. So you can see kind of the basic status of the cluster. So the Files tab up here at the top gives users access to a simple file browser of things in their home directory. You, as the administrator, can define which paths they have access to. By default, their home directory is one, but here you can see we have a scratch directory and a temp directory that the user could access. In a configuration file, as the administrator, you can define what these paths are. And you'll see that they can see all the different files. They can click here and view a file. So shows you the contents of a file. If this was a log file, they could choose tail, and this is an equivalent of a tail minus F, and it will update every 10 seconds. So as a job is running, a user can easily get the status of that. And they can also download it. So very large files, they'll be able to download directly onto their desktop from this interface. And you can easily browse into subdirectories, that kind of a thing. So very convenient, very easy way for users to look at the status of their jobs and files that are in the path that you want to give them access to. So there's a Reports tab. We'll go ahead and skip over that for now, and we'll head over to the Submit Job tab, because that's where the most interesting parts are. So what you see here is a directory and path structure of job forms. So the way we decided to split this up was based on batch and desktop apps. So this is completely definable by you as the administrator. You can decide what directory structure of applications. You can set permissions on the directory level or on the individual application level. So if we go inside batch here, you can see we've built forms for a couple of sample applications, GrowMax, HPL, LAMPS, etc. So if we take a look at the LAMPS job here, what we get is a form that was designed around the LAMPS application. So when we were thinking about LAMPS, we know we wanted to ask a couple of questions. The name of the job, the queue they'd like to run their job in, the LAMPS input file, do they want email notification, and the number of cores. So this is part of the UI element that the administrator has control over. You can see there's a text box, there's drop downs, there's files, there's sliders. So as an administrator, when designing these forms around particular applications, you can choose what makes sense. So I'll go ahead and submit a LAMPS job here, so you'll kind of see how this works. So I'll go ahead and call my job LAMPS, and then all queue is fine. So, and now I get this file picker choice, where I can either choose to upload a file from my own computer or pick a file from the cluster. If I click upload a file from my own computer, you'll see I get a file browser. I don't actually want to do that. I want to pick a file that's already on the cluster. And you can see the UI element changes, and I get a select box. So I know that inside my demos directory, and you can see by default it's put me in my home directory, and that's completely definable by you as an administrator which paths they can pick files from. I know inside my demos directory, inside my LAMPS, that I have a file here. So I can choose that. I can type in my email address if I wanted to get email notifications. And let's say I want to run this on 40 cores. And then I can hit the Submit Job button, and job number 292 has been submitted to the cluster. So as an end user, if I know I need to run LAMPS and have data to run through it, but I don't know how to do all the rest of it, that's all I have to do. I don't have to learn how to upload files. I don't have to learn how to create job submission scripts. I just click the buttons. So if we flip over to the Job Management tab, we can actually see my job that was submitted. Job 292, the state, where the owner, the running time, the number of nodes, the slots that have been assigned. If I click on the job ID here, I get all kinds of detail about the job, but directories where it's been run are highlighted for me. So I can click on here, and I can start seeing all the output from my LAMPS job. So this LAMPS job happens to drop image files, so I could click here and choose View, and I can actually view the output of those image files right in my web browser. Or if I wanted to look at the output from it, I could click Tail, and actually see the output of my running LAMPS job. So very simple, very easy way for a user to be able to look at all of this data and submit jobs and run jobs on the cluster where before maybe that was difficult for them. So the interesting thing here is this LAMPS job will also drop some files that we can visualize within VMD. So if we flip back over to submit job, we can go to desktop apps, and then I have VMD down here. So this is another form, very similar to the other one. It's you define this as an administrator, which questions to ask. So we'll go ahead and choose these things, but we'll go ahead and pick the input file we want to load. So if we go into our our eQUEUE directory where it's running our job, and then we can pick our output file that was created from our previous run job. I can hit the submit job button. What will happen now is this will spawn a job on the cluster. This will start a VNC session on one of the nodes on the cluster, and then download a very tiny Java web start definition file. I click on this, and then Java will start up on my other monitor here. But then what's happening here is the Java session, or the VNC session, is being tunneled through the system running eQUEUE over SSH. So what we'll do is ask for your SSH authentication information. So you enter the same passwords you normally use to SSH the system or to pull up the eQUEUE itself. And this is on another monitor here, and you can see that LAMPS has been started on a node, and you can see at this time it's actually running on GPU 01 of the cluster with the file preloaded for me. So I can do some, let's see, change some coloring of this real quick so it looks a little more interesting. There we go. So, and we can actually adjust the speed and see that this was actually an animation that was created from that LAMPS job run. So I have full control over here to spin this around. And again, this isn't using the 3D card on my workstation at all. It's using the 3D card on GPU 01 inside of our cluster. Because this is running through the VNC session, we can do some kind of nice features. Like we can go up here and just close this window. So I went ahead and closed out the session, but it's still running. And if I go back to my job management screen here, I can see that my job 293 is still running on the cluster. And I have the new button besides the delete. To delete a job, I have this little eyeball. And the eyeball allows me to connect back into the session. And it will start the Java web start again. And then ask me for my password. And you can see it pulls my session exactly where I left off. So you could disconnect, go to another computer, go home, what have you, and still be able to connect right back where you left off. Now, since this is a job that still runs within the queue and is just another job, you can put all the same rules you would have that you would normally have for batch jobs, wall time limits, running time, memory utilization, that kind of a thing. So even if somebody does disconnect from a session, they can't keep it open indefinitely. So I'll go ahead and quit. If I quit the application appropriately, my session will close. And now if I go back to my job management, we see that it's now gone. So not only do you get the ability through the job management to see your current running job, you also have a job history tab here. And the job history tab gives you the details of previously run jobs on the cluster. So this pulls data from the accounting log, and you can see my LAMPS job I ran, a desktop job I ran earlier. It takes a few seconds here, but we'll see there's the VMD job that just quit. So, and you can see the start time, the queue, how long it was queued, how long it was run. And then we also give some really useful information to the user here about their average run times, the nodes that they normally request, the memory utilization and average and maximum. And then there's a full time selector here, so they could look at the last 30 days, this month, last month, a custom range. So the user has a really good ability to kind of go back through and look at their past jobs, see how much memory they've used, see if their jobs have run well, etc. So earlier I ran an HPL job here, and you can see it took 21 minutes to run. But the reason I did this job, and it ran across 60 nodes, is to show you kind of an interesting feature of data collection that we do. When I click on the little eyeball here, we get some information about that job. So this gives us memory utilization, CPU utilization, and swap utilization on the nodes that ran my job during the time period the job ran. So you can see the CPU utilization. So it starts here at the Overview tab, which is a summary of all 3 nodes in this case, since we ran on 3 nodes that are running the job. So you can see, the CPU utilization, the memory utilization, was I utilizing any swap? And then I can also drill into each individual node and see if there was a problem with my parallelization. Did it run correctly on all 3 nodes? Did one node die off sooner than the others? So you can get a really good feel for, is my job running correctly? Is it working well? So that gives a nice insight feature to the end user. And that data collection is at a user-defined interval. By default, it's every minute it collects the data, but if you want more precise or less precise, that's something that you can adjust as an administrator. So let's go back here and get a little more in-depth at actually making a job submission form. So what I'm going to do is now give kind of a live demo, an example of building a job submission form for compressing files. While compressing files may not be the most useful feature or job to run on a cluster, I figure it's something everyone kind of understands, and you'll get a feel for how easy it is to build a job form and what you can do with that. So what I'm going to do is log into the system that's running eQUEUE. So under Act eQUEUE Forms is the directory where all the forms are for the job. I'm going to go ahead and become root because that's the permissions on these particular files. But if I do an ls here, you'll see that there's 2 directories, batch and desktop apps. And that corresponds with what we see here, batch and desktop apps. So the structure of your forms is very simple. You want to make a new form, you make a new directory, or make new files in an existing directory. It's very simple to do. So if we go into the batch directory, we can do an ls, and you can see there's GROMACS, HPL, LAMPS, NAMD, R samples. So that corresponds with what you're seeing here. So I'm going to make a new job. I'm going to call it compress. So I make a directory called compress, and then inside the directory, I'm going to make 3 separate files. The first file we call settings. And we use a very simple INI style syntax, where we say the description of the job. So this part will show up underneath the name of the job right here. So, and then we're going to add, we can add some permissions in here. Let's say only John Doe can use this form, and only the group chemistry can use this form. And you can replicate these user and group elements as many times as you want to allow as many users, separate users or groups, access. If you take these elements out of your form, then it's access available to everyone that has a login. So we're going to go ahead and leave this open. So now if we go ahead and reload over here, we now see compress. So the next thing I'm going to do is actually design the form. And again, it's another INI style file syntax, and there's a complete documentation to all of this. But I'm going to go through this fairly quickly just so it's not too boring to watch someone type. But I will highlight some important parts as I go. So the first at the top, there's a special section called config of your form. There's 2 options when jobs are run. There's the idea of creating a job for a directory, a spool directory for a job, or selecting an existing directory. So the creating a directory by default will create a spool directory inside the user's home. So for every job that gets run through eQUEUE that has job create as true, a temporary directory is made for the job to run. A job select directory is the user will pick the directory where the job should run. So the idea here is if you have something that needs a lot of prep work, a lot of input files created, edited, stuff already in place, you might use the select. So that way the user can pick the directory that exists already, that's already ready to run their job. But if it's a very simple job, like our job is going to be of compressing files, we don't need them to pick the directory ahead of time. So the next option here is we're going to create some variables. So anything inside square brackets other than the underscore config is a variable that can be then used later. So the first one we're going to create is a type of text, and it's going to have So if I go ahead and save this, what you'll see now, if I go into my compress form, I now have a nice text label at the top that says create compressed files. So the next thing I'm going to do is ask the users for the files they want to compress. So the type element inside of your INI syntax here is the type of form element. So text is one, file paths is another one. So, and you'll see what this looks like in just a second. So we say select the files to compress. And then we give it a root and say home. So by default, we want users to be able to pick files that they want to compress, but only be able to pick them from their home directory. We save this and go back and reload. So now we see we have a new form element that says select files to compress. If they click select files here, it's dropped into the user's home directory, and I can select multiple files that I want to compress. And you can see they fill out the box. So I want to be a little more detailed and let them pick directories as well. So I have a different element called dir paths instead of file paths. So this would be to select the directories. So we don't want the user to have to select all the files individually if they want a whole directory. So we'll add another element and a select, which is a select box. So, and we'll give them a couple of options here. Let's say we want to let them gzip some files, we want to let them bzip some files, and we want to let them use regular old zip. So if I save that and go back over to my form, you can see I have now select the files to compress, select the directories to compress, and I have a nice little drop-down box. And the last question I want to ask is an input text box, and then I want to ask the name of the output file. So put space there, and we'll tell them to leave off the extension because we'll figure that out based on what they selected in the type field. So, and we'll pre-fill it out with the value output. So now if we reload, we see we have a new box here. They can fill it out. But it's pre-filled out already for them. So we have half of our new job form created. So now we'll go ahead and create the submission file. So we create a file called submit. And again, this is going to run on the cluster. So we start building a job submission file. And this is using Grid Engine, but the same idea applies to Torque here. We would just change, in Grid Engine, the syntax is the $$ inside your files, and Torque it's $PBS. So same ideas really apply across multiple of these, but we'll just use this as an example. So I'm going to say I want it to run in my all queue. So now I'm going to do a little scripting here that is built into these submission files. So all of the variables, what I'm going to do here is split my VI screen so you can see all of the variables that are in the square brackets. All of these are variable names that are available in our job submission script. So what I'm going to do is take the files and DIRs variables up here and join them together. So those are arrays that can be looped through inside of your job submission script. But I don't need an array, I just need a space-separated list. So what I'm going to do is say set all directories equals, and again, all of this is documented, but so what's going to happen here is I'm going to get a new variable called all directories, which is each directory the user selected in the UI separated with a space. And I'm going to do the same thing for all the files. So now I'm going to do if type. So as you can see, we have this variable up here called type, and the values are going to be gzip, bzip, or zip. that I'm going to do so we're going to issue the tar command and then use output.tar.gz as the file name, and the output is whatever they typed in the output box. And the arguments to the tar command will be all the directories they selected and all the files they selected. So now I'm going to do an else if type is bzip2, and then an else if type equals zip, and kind of replicate this. And then this will be the zip-r command. So, and now we just end our if statement. And now we have a job submission script. So, if we go back and reload our form here, I can choose select files. So I'm going to go ahead and select this file and this file. And then I'll go back in here, choose select directories. I'm going to select this demos directory. So I'm going to say gzip is fine. I'm going to say my output file is the name of the file I want to create. I click the submit job button. A job is submitted to the cluster. So job number 294. So if I go to job management, I can see 294 is running. I can click on 294, click here, and see that I have my output file.tar.gz. So I can view the output from the job. So it's going to remove directory names, and we'll start compressing the file and generate our output file. So you can see how easy it is to build job submission forms around applications. Again, file compression isn't necessarily the best use of a cluster, but it's an idea of what you can do. And then you can take those and do more complicated jobs. So for example, if we go back to our lamps job, we can show you what that actually looked like. So we went into our lamps directory and looked at our form. You can see the questions that we asked here about job name, about queue, the input, the slider here that allows us to say between 1 and 80 cores, a step of 1, a value of 16. And then we have the submit option here where you can see we're actually doing submitting to a queue, we're loading modules, we're running an MPI job, much more like you would expect to see on a cluster job. So that's the basics of job form creation. If there's any particular question, feel free to ask those in the questions. We'll go ahead and move on to the reporting tab, which is kind of the last major feature that we wanted to highlight. So what the reporting tab is and it is configurable to only show to administrators. So in the configuration file for eQUEUE itself, you can define which users have access to see this data. But this gives you kind of an overall view of your entire cluster. So I'm going to go ahead and do a custom date range here and do, I'm going to do last year, so January through December. So what I've done here is loaded some data from one of our customers and one of our beta testers of all of their jobs and all of their accounting data from last year. It's a 200 node cluster that this is running on, but it'll give you a feel for the kind of data you can actually see. So we can get some nice totals here, the total number of jobs that were run, how many unique users, how many unique groups, the average runtime, the maximum runtime, the average queue time, the maximum queue time, what their nodes, their quantity of slots and cores, the memory utilization that's average and maximum for their system. And then it breaks it down into a lot of detail here. We have a set of tabs in the middle of the screen. So we've got users, we've got groups, we've got queues. So under users here, we can see, who's submitted the most jobs to our cluster, what kind of jobs, by default, these are using one node. So I've, as a ability to use this data, they've asked me to anonymize all the usernames. So that's why you're seeing user numbers and not actual real usernames. But this is real live data from a cluster that's been in active utilization. So But if you want to drill into a particular user, for example, if user 67 is saying that they're having, why are their jobs queuing so long? You can go ahead and click on here, see, their average queue time is an hour. But they have had a maximum job or one job that's queued for 34 hours. So I can go in here and say, let's take a look and see what is the job that queued for 34 hours. And we can see, looks like all of their jobs have been submitted to a queue called batch, except for this one that's big min. So maybe that's why it took longer to queue. But at least you can easily drill down into the job number they're talking about and see kind of the details. And again, where this was not always the most obvious and easy way to get at this data. So not only do we have information based on queues or on users, we have it based on groups, which is basically the same thing. In this cluster, almost all the users are in this group called cluster users, and they don't have subgroups. But if you, on your system, you have lots of different Unix users, you have the ability to pull all of that by that kind of category. And also, all of these particular tables of data here, you can copy this all to your clipboard, you can export a CSV file or get a PDF from it. So you can take this data, throw it into your spreadsheets, do lots more useful information with it. Queues gives you a rundown of all the individual queues, so you can see what's going on in all of these individual queues. Categories and tags was a requested feature from another beta test site that allows you to subdivide your users into separate groups. In this case, they wanted to have departments, but they didn't always use Unix groups to define those departments. So there's a command line tool called eQUEUE user tags where you can define and add individual users into different departments. So you can see we've added 3 separate unique users into the biology department. So now we can start to kind of sum up and see which subset of our users are using the system the most, how much time are they using. And again, you still have full access, so if you click on physics here, it'll pop it up and give you all of the details of those individual jobs that have the Department of Physics. And you can define as many categories. So you see we have department and user type, for example. So we decided for user type we had a category called, or a tag called student, but you can have a tag for staff. Whatever makes sense for you guys is a way to be able to define these. So it's just another way to subdivide the data and get useful reports out of it. Disk utilization works very similar to the tag and allows you to load data in. We ship with some default tools to load in Unix quotas, Linux standard quotas in, so that way you can view file system quota and information here all at one place. It's just a nice feature to be able to see it all in one user interface. Time of day gives us graphs and utilization by the time of day, so we can see when is our cluster most utilized. So you can see it by jobs, by nodes, by slots or cores, by unique users, by unique groups, so you can get a feel for when are people really using this cluster. Day of week, so same kind of data, but you can see that Tuesday clearly is the busy day. Weekends drop off pretty heavy, but that gives you a good insight of how your system's being used. As well as you've got month of year here, so you can see which month and time is really most active. So here we can see that it looks like June is a super busy month on the system. So that is kind of the main overview of eQUEUE and the web interface. There's a lot more here. There's some other features that we could go over, but I want to keep this fairly short, and so that way we don't take up too much of your time. So we'll go ahead and switch back to the slides. So, and I only have a couple more slides. So, common question here is how much does this cost? So, and this gives you a breakdown of, we get quantity breakdowns on nodes. It's a perpetual use. It doesn't expire. Maintenance and software updates are included with your price. So if you pay for the 3-year, you'll get updates for 3 years. Tech support is also included in all of this. So there's a 25% discount for educational pricing. And then there's also another additional, I'm sorry, skip the slide there, 10% discount if you're installing this on our hardware, but there's no reason it has to be on our hardware if you have an existing system. So if you have greater than 512 nodes, certainly call us and we can work out a special price quote for that. Also, we're offering a discount for anyone that attends the webinars. They'll get an additional 10% off. So we'll be able to combine all of these discounts together. So, if it's a educational institution and they're on our hardware and you attended the webinar, you'll end up with a 45% discount off the list price. So that's kind of the end of the webinar, and I have any time for question and answers. If there are any, feel free to submit them now. So there's also a link here to get more information, and then I have a set of polls here that, if you can download in the bottom corner, you can download the presentation. There's also a data sheet that you can choose to download, and then there's also some links to the site and some polls here. Would appreciate having them answered, and if you have any questions, like I said, feel free to submit them here or send us an email afterwards. We'll also, as I mentioned earlier, this is being recorded, so we'll send out a follow-up that has this recording, so you can choose to watch it again or pass it on to anyone that might be interested. So I'll leave this open for a while. If you don't have any questions, feel free to disconnect. If you do have any questions, feel free to ask them now in your Q&A box, and I will
We do have one
happily
question.
answer them. Okay.
Somebody's wanting to know how they collect the resource information from when the job is running.
So we integrate within Ganglia for that. So we're pulling the data from Ganglia to get that information. So there is a background daemon that runs on the eQUEUE system that does that data collection at an interval you define. By default, that's every minute. All right. Well, we'll leave it open for questions for another minute or two, and then otherwise, I appreciate your time for attending, and like I said, we will be following up with the slide decks and information as well as ability to access this recording. So again, appreciate your time. And I see there's a new questions. Will the discounts apply for 1 year only? No, the discounts will apply for the life of the system. So your renewals, there is a lower cost to renew maintenance, and you will get the discounts at that time as well. I'll go ahead and show the results of the scheduler so you guys can see what other people are using as well. Will the renewal prices change? The renewal price is 25% of your initial purchase price. So it will be the same throughout the life of the system, or the life of the renewal, I should say. But we can certainly contact you with more information on all of the pricing models and things like that. So I have another question here. We have 2 clusters. Does this work across both at the same time? I guess the question would be if the clusters are connected. If there are unique individual clusters, there is no grid functionality at this point. You would need to install it on each cluster. If you can submit jobs from one cluster to the other cluster, then yes, it should work. But if they are 2 completely separate instances, then that would not work. And you would have to install it both times, or 2 times. Okay, well, I think we'll go ahead and end the session now. Like I said, don't want to take up too much of your time, but we will be following up with the slides, and if there are any more questions, feel free to contact us. You can email, as in the note here on the screen, sales at Advanced Clustering. If you have technical questions, there is a ticket system at eQUEUE at advancedclustering.com. You can send that there as well. We'd be happy to answer any questions you might have. All right. Well, again, thank you everyone for attending.